So we're now going to start chapter 7 of Pure Year 2, which is about trigonometry. So first of all, don't open the textbook, because what we're about to figure out is given away. So normally the way I like to do this in class is a group exercise to figure out, well, essentially, in a moment, you're going to pause the video and have a go at labeling as many different sides and angles in this triangle as you can. I've forgotten an important piece of information, which is that the diagonal AE is of length 1. And the goal, what we're trying to do, is to work out or to find a formula or formulas for sine of alpha plus beta and cos of alpha plus beta in terms of sine alpha, sine beta, cos alpha, and cos beta. So what I want you to do is to think about, firstly, where can you find on this diagram the sides that have length, sine alpha, sine beta, cos alpha, and cos beta. And maybe start by thinking about where you're going to find sine beta and cos beta, and then think about if you can work out any of the other sides in terms of these four things. But eventually the goal is we want to find an expression in terms of these four things for sine alpha plus beta and cos alpha plus beta. So also think about where you can find these on the diagram. Okay, so I want you to just pause it now, have a go. Maybe if you get really stuck, then, well, in a minute, if you watch it again, then I'll explain how to do it. So pause it now. Okay, so now we're going to show how to find formulas for these expressions. So let's just first do some angle chasing. So what I mean by that is let's just label all the angles we can find. So, well, many of them we're not going to need, but this one up here is 90 minus alpha, isn't it? Which makes this alpha, because this is a rectangle. So these two again are 90 minus alpha, or pi by 2 minus alpha, of course, if we're in radians. So for this, it doesn't matter if we're in degrees or radians. And then this is a right angle here at C, so this is 90 minus alpha, which makes this angle at the top of the right angle triangle EFC alpha. And, okay, so, and then this angle up here, well, if we look at the triangle AEC, if we look at the triangle ADE, even easier, this angle at A is alpha plus beta, so this is 90 minus alpha minus beta. Then this one is going to be alpha plus beta again. So now if we think about the triangle AGE, say, then we've got a hypotenuse of 1. The angle at E is alpha plus beta. What is the opposite side, AG? It's my initials. Well, AG is, or rather sine alpha plus beta is AG over the hypotenuse, which is 1, so that's just AG. So AG is sine alpha plus beta. And then, so obviously by the same reasoning, ED is also sine alpha plus beta. And by a similar argument, cos alpha plus beta, is GE over 1, which is GE, which is also AD. So GE is cos alpha plus beta. Okay, now, can we find a different way of expressing these sine alpha plus beta and cos alpha plus beta? So let's come back to this question of where can we find cos beta and sine beta on the diagram. So if we look at the triangle AEC, there's an angle beta at A, and there's this hypotenuse of length 1. So this side EC here is opposite, so it's going to be sine beta. And the angle, sorry, the side AC is going to be cos beta by the same reasoning. It's a bit hard now to fit everything on the diagram, but AC is cos beta. And let's redraw the triangle ACB. So here's A, here's B, here's C. This was cos beta, this angle is alpha. So it's a right-angled triangle, the hypotenuse is cos beta. So if we work out sine of alpha using this triangle, we get BC over cos beta, which tells us BC is sine alpha cos beta. And if we do the same thing for the other side, cos alpha is AB over AC, which is AB over cos beta. Therefore, AB is cos alpha cos beta. So we've got some more things. We've got this whole side AB is cos alpha cos beta, and this height BC here is cos beta sine alpha. And then if we're doing pretty well so far. If we use the triangle ECF, so it's got hypotenuse sine beta and angle alpha at the top. So this was E, I think it's like this. And let's work out the other two sides then. So sine alpha is going to be CF over sine beta. So therefore CF is sine alpha sine beta. And by the same reasoning, we can probably guess that the other side you can show is cos alpha sine beta. So we've got this side EF is sine beta cos alpha. And it's almost too much to fit on this diagram now. But notice that the height AG is sine alpha plus beta, but it's also EF plus FD. And we know FD because it's the same as BC. So we can say the height, sine alpha, so we're using the AG is EF plus BC. AG we know is sine alpha plus beta. EF we've just worked out is sine beta cos alpha. And BC we worked out earlier is sine alpha cos beta. And so we're done. We've got a formula for sine alpha plus beta in terms of sine alpha, cos alpha, sine beta, cos beta. And similarly, if we look at the width of the rectangle, AD, which is the same as GE, AD is the same as AC, which is the whole length, sorry, no, not AC, AB, which is the whole width of the diagram, minus BD. And BD, of course, is the same as CF. So this is AB we worked out was cos alpha cos beta, and BD is CF, which is sine alpha sine beta. And then we said at the beginning AD is the same as GE, which is cos of alpha plus beta. And we've got a formula for cos alpha plus beta in terms of the things we wanted. Okay, so this proof is examinable. You do have to know this. However, it's never been tested before that I've seen. If they were to test it, they would almost certainly give you some version of this diagram or a similar diagram, probably potentially with parts that would lead you through the proof. So yeah, so this is kind of important. I think it's much better to see the proof than to just state these two results as facts. In our diagram, we assumed alpha and beta are acute, and in fact we assumed their sum is less than a right angle, but these two formulas actually holds for all angles alpha and beta in the real numbers, even negatives and even very large angles beyond 2 pi, and if we're in radians and so on. So so yeah, these are really useful. They're called the addition formulas. And we can actually, so in the book, question 1 of exercise 7a is about a really similar thing to this, a similar diagram for proving formulas for sine alpha minus beta and cos alpha minus beta. But actually, we don't need to do that to prove them. If we make this assumption that I'm telling you is true, that they're true for all angles. So, in fact, if we wanted to work out the formula for sine alpha minus beta, we could replace the plus here with a minus. And then we replace beta everywhere with minus beta. So we get sine of minus beta cos alpha plus sine of alpha cos of minus beta. And then if you think about some trig graphs, if you think about the sine graph, it's you'll know that sine beta is minus sine beta. If beta is up here, then minus beta is down here, and we see that this is true. But the cos graph is symmetric about the y-axis, so the difference there is, sorry, I don't know, that's not right. What I mean is if beta is here, then minus beta is over here. So then, yeah, and here if beta is here, we see it's symmetric, so cos minus beta is the same as cos beta. So we have sine alpha minus beta is sine alpha cos beta minus sine beta cos alpha. So these are the subtraction formulas, and by the same reasoning, using these facts about cos alpha and cos beta, we get this time the sine minus beta again becomes minus sine beta, so we get a plus instead of a minus. And that gives us the 4 formulas. Good news, all in the formula book. So these 4 formulas I put in boxes, red and blue boxes. They're all given in the exam. You don't have to learn them. The way it's written in the formula book is like this. I think they use maybe A and B in the formula book instead of alpha and beta, but they give it in this form. And obviously the plus at the top corresponds to the plus at the top, the minus corresponds to the minus. So this is, for the other one, of course, we get a minus plus here. So minus plus, that just means the plus here corresponds to the minus there. So that's just something to be aware of when you're using the formulas in the formula book. Okay, so now how about tan? We've got sine, we've got cos. Is there a way we can work out tan? I don't know why I switched to using A and B. Let's go back to Greek letters because it's more interesting. So tan alpha plus beta. Well, we know tan is sine over cos. This is sine alpha plus beta over cos alpha plus beta. And then we've got formulas for these. We've got sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta, and cos alpha plus beta is cos alpha cos beta minus sine alpha sine beta. But say we want an answer in terms of tan alpha and tan beta. Can we do that? Is there a way we could make that happen? So is there something we can divide by that would turn everything into tans or ones? And the answer is yes. If we divide both the top and bottom of this fraction by cos alpha, cos beta, so doing the same thing to the top and bottom won't change the fraction. Well, doing this if you multiply or divide by something, that is. So if we divide everything by cos alpha, cos beta, so it looks like it might be really messy to do that, but it's going to work out quite nicely because sine over cos is tan. So everywhere we have sine something over cos something, it becomes a tan, and many things cancel. So first let's just cancel everything that cancels. So here everything cancels, we just get a 1. There nothing cancels. So what are we left with? We've got sine alpha over cos alpha, that's tan alpha. Sine beta over cos beta is tan beta, over 1 minus sine alpha over cos alpha is tan alpha, times sine beta over cos beta is tan beta. So this here is the formula for tan alpha plus beta. And similarly with a minus, if we replace beta with minus beta, we're going to get the signs change. So tan minus beta is minus tan beta. So in the denominator, we're going to get a plus, and here we're going to get a minus. And then these two formulas here are also given in the formula book. Good. So now on to just a couple of... So there are quite a few questions about proving things in this next exercise. So we'll just see some examples of that. So here's a question. Prove that cos A over sine B minus sine A over cos B is cos A plus B over sine B cos B. So trig proof, not everyone's favorite thing, but there are often strategies that are helpful. So here it helps to notice that we could combine, if we start with the left-hand side, and it is good with a trigonometry proof to start with one side and then do a bunch of steps that take you to the other side. It's kind of seen as bad practice to start with both sides and then try to work to something in between. Although technically that's valid if you can make it work. But the reason I want to start with this side is I can combine everything into one fraction. You might be thinking also, you could start with the other side and then use the addition formula. That would be perfectly valid as well. But I quite like the idea of combining everything into one fraction. So the common denominator is going to be sine b cos b. So then to make that happen, we need to times the top of the first fraction by cos b and the top of the second fraction by sine b. And then notice on the top, we've just got the addition formula for cos. So we have cos A plus B over sine B cos B, which is precisely the right-hand side. So we're done. And then one final example. So given that 2 sine x plus y is 3 cos x minus y, the question is express tan x in terms of tan y. So this is reasonably difficult question at this stage, I think. So let's see. So obviously we're going to have to use the addition and subtraction formulas. So a first step would be to rewrite everything using the sine x plus y formula and the cos x minus y formula. So sine x plus y is sine x cos y plus cos x sine y. And then the other formula, cos x minus y, is cos x cos y plus sine x sine y. And then, okay, this isn't looking particularly rosy, but we want to get tan x and tan y. So remember this trick of how we got tan formulas here. We divided everything by cos alpha, cos beta. So I'm going to suggest that if we divide everything by cos x, cos y, that's going to be really helpful because it will give us stuff in terms of tan. So we're going to get 2 sine x cos y over cos x cos y plus 2 cos x sine y over cos x cos y equals 3 cos x cos y over cos x cos y plus 3 sine x sine y over cos x cos y. And then we cancel everything we possibly can. Yeah, and then we're going to get 2 sine x over cos x is tan x, plus 2 sine y over cos y is tan y, equals 3 plus 3 tan x tan y. And then we need to find tan x in terms of tan y. So now it's just a rearranging formula question. So we're really being asked to make tan x the subject, and tan x appears twice, so it's just like GCSE rearranging formula. Get all the tan x's on one side, and put everything else on the other side. And then factorize tan x out, and then we're almost there. Now divide by 2 minus 3 tan y. And that's it, that's the answer. Done.